In this session, we're going to solve Math 11 20 Tutorial Sheet 1 2026. If you are new to our channel, kindly subscribe and you can also like this video. So these are the questions that we're going to solve in your tutorial sheet. We're basically going to solve all of them. So let's start with the first question. Now we're told to let the universal set to be this range. And then we're given that A is a member of the universal set and A is a factor of 12. B is 1, 3, 4, 5, and 6. And C is that. Then we're told to find each of the following sets. So let's start with A. But first, what are we given? We are told that the universal set, it is between or starting from 1 to 9, okay? Because x is such that x itself is greater than or equal to 1 and x is less than or equal to 9. So in this case, the universal set is just going to be 1, 2, 3, 4, 5, and 9. Okay, so we've included 9, we've included 1 because the inequality there also equals to that. Okay, so basically that. Now we have to also list what A is. We've been told that A is actually x is a factor of 12. Okay, factors of 12 are those numbers that can go into 12 from this same list of the universal set. So in this case, what are they? There is 1, there is 2, there is 3, 4, 6 can also go into 12. Of course, there is also 12 itself, but we're not going to include 12 because look at our universal set, it's ending at 9. Okay, so therefore A is just going to end there. Then what can we also list? We can also list B. B we have already been given, it is 1, 3, 4, 5, and 6. Then we are going to come to C. C we've also been given, it's 2, 4, 5, and 7. Okay, so let's start with the first one. We've been given to find A minus C. Okay, so since we know what A is, we know what C is. Here we're just trying to remove C from A. Okay, so C in this case we've got 2, 4. Then in A we've got 2, 4. So there's 3, 6. Okay, so what this means is that I'm just going to list what A is, which is 1, 2, 3, 4, and 6. That is A. Minus C, we've got 2, 4, 5, and 7. Okay. Now we're told to remove C from this set. Okay. So in C there's 2. So we're supposed to remove 2 also from A. In C there's 4. We're supposed to remove 3 also. There is 4 actually. We're supposed to remove 4 also from A. Okay, so from A what that remains, we only have a 1, a 3, and a 6. Okay, we can't remove a 7, we can't remove a 5 because those ones are not in A. So basically this will be the solution for A minus C. Let's go to the second one. Okay, I'm just going to use this same one. So for the second one, we've got B minus A, then there's intersection C. Okay, so B minus A, if I'm going to write my B, B is 1, 3, 4, 5, and 6. Then you're subtracting A. A is 1, 2, 3, 4, 6. And I must make mention that you can solve these questions in whichever way that is very, convenient for you. But just make sure that you get the correct answer. So in this case, we're removing A from B. Okay. So let's start. In A there is 1. In B there is also 1. So I'm going to remove that 1. In A we have a 2. In B we don't have a 2. In A we have a 3. In B we have a 3. I'm going to remove the 3. In A we have a 4. In B we have a 4. In A we have a 6. In B we also have a 6. Basically B minus A will just give us a 5. Okay. Then there's an intersection there. Then we're intersecting it with C. So in this case, what is C? C, you're able to see that we've got 2, 4, 5, and 7. And we're finding the intersection, okay, of that. So you're able to see that we only have 5. Okay. There's 5 in C. There's also 5 in B minus A. So in this case, B minus A intersection C is just equals to a 5. Okay. That was our B. We come to C. Okay, so what do we have as C? We've been given which one can we solve? We can also solve A intersection C, then complement. Okay, so this is just one of the simplest ones. If you want, you can distribute this according to the Morgan's law and you solve. Or you can solve what is in the bracket and find the complement. I'm going to go for the latter. So I'm going to have A intersection C. So what is the intersection between A and C? So I've got a 2, I've got a 2 there. I've got a 4, I've got a 4 there. Then I hope I haven't left anything between A and C. I think those are the only ones I'm able to see. So 2 and 4. Okay. So 2, 4. Okay, then there's a complement. You're trying to find the complement of that. So it means you are going to go back to your universal set. So from the universal set, all the elements that are not 2 and 4 will be your final answer. So in this case, we're talking about 1, 3, 5, 6, 7, 8, 9. Okay. So basically that. Then yeah. So that's how we just solve these equations. You can also try out E. You can try out F. Basically, that is how we solve these ones. Not very, very complicated. Okay, so let's solve the next set of questions. We come to question number 2. We're told to let A to be 1, 3, 4, 5, 1, 3, 4, and 6. Then B is that, C is that. And the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the universal set is from 1 to 10. Then we're told to verify this and that. Then this and that. Then this law and that law, that law and that law. Okay, so before we even start solving, this question has sufficed almost in all the tutorial sheets. It's always there. So here we're just trying to verify the first law, this one, to that. This is called the associative law. Okay. And if you haven't yet understood the associative laws, please you can watch any of our videos on the same set laws. You're going to find it was well explained. Then this and that. Okay, it's the same associative law. Okay, then this and this is the De Morgan's law. Okay, So here we're just trying to prove the associative law and the De Morgan's law, and it's always simplified. I always just say if I've got 1 plus 2 plus 3, okay, and if I say I've got 1 plus 2 plus 3, what this means is that if I'm going to put the first 2 in brackets, then I solve. I also put the last 2 in brackets, then I solve. I'm going to get the same answer. That is the basic premise about the associative law. If I've got 1 plus 2, that is a 3. Then I'm adding it plus this 3, it will give me a 6. This is my left hand side. When I come to my right hand side, I've got a 1 plus, according to your board mass, add what is in the brackets. 2 plus 3, that is a 5. A 1 plus a 5, that just gives us a 6. So able to see that the left hand side and the right hand side are giving us the same answer. This is according to normal algebra. So someone said, okay, actually also with sets it's the same. If I've got A, I've got B, I've got C. I've got A, I've got B, I've got C. Let's say now I put if I start first with this first law, where we have the intersection throughout, here we're using plus throughout. If we use multiplication, we still get the same answer. So if I put intersection, intersection, also there intersection, intersection. If I start with okay, let's just follow the way it is in the question. If I start with the first or the last 2 sets, I'm still going to get the same answer if I start also with the first 2 sets. So basically that is how that law is coming about. But if you really want more details, please kindly just review our video, check on it on this same YouTube. You are going to find us explaining about the same law. So now let's just now try to solve our question. So for these laws, I think I'm just going to solve not all of them. I'm just going to solve one of the laws, okay? Then the other one is just automatic. Okay, so let's go for the union one. Let's say here I've got we've got A, where is it? It's A union B union C is equals to A union B union C. Okay, so basically this is what we have. Okay, let's see what we are going to have. So first of all, you have to find out what B union C is. What B union C is. So in this case, what is B union C? So B union C will just be equals to, we're just trying to find what we have both in B and D and in C, and we combine. So in this case, in B we've got 2, 4, 6, 8 and 10. In C we've got 1. So I'm just going to start with 1 in C. I go to, there's a 2 in B, there's a 4 in both B and C. There is no okay, there's a 5 in C, there's a 6 in B, there is no 7, there's 8, there's 10. Okay, so basically that is B union C. Then we have union A. So to this same set we have to add A as well. Okay, union A. So now if I add A, so in this case A union B, okay, union C, like that, it's just now going to be, if I also add you know, A there, what are we finally going to like have? In A we've got 1, 3. Okay, we've got 1, 3. We've got 4, 6. Okay, so what we just don't have in this set is a 3. So we're just going to add the 3 to make the sets now complete. So in this case we're going to have 1, 2, 3, 4, 5, 6, 8 and 10. That is this set. This is our left hand side. Now let's go for the other one. For the other law, we've got A union. Okay, let me just write on the left hand side. We found that it is 1, 2, 3, 4. Okay, that is what we have on the left hand side. Allow me to just rub a bit here. Okay, we've already found our answer there. Okay, let's move on the right hand side. On the right hand side, I'm supposed to find what A union B is. So A union B, we're combining. In A we have 1. Okay, in B we have 2. We have 3 in A. We have 4 in both. We've got, we don't have a 5, we have a 6 in B, and also in A, we have an 8 in B, we have a 10 in B. So that is A union B. Then we are uniting this one with C. Now when we combine with C, this is A union B, union C. When we combine with C, what do we get? Okay, so in C, what is unique about C? C has 1, 4, 5, 6, 8. Okay, so it has 1, 4, 5, 6, and 8. So we're just including 5 in this set that we have. So in this case, we're going to have 1, 2, 3, 4, 5, 6, 8, and 10. Okay, basically that. Now we're supposed to compare these two sets if they are equal. Okay, otherwise that is what is going to confirm if really indeed the left hand side is goes to the right hand side, and if really indeed it is the associative law. So we've got 1 there, we've got 1, we've got a 2 here, we've got a 2 there, we've got a 3, we've got a 3, we have a 4, there's also a 4 there, 5, 5, there's 6, 6, 8, 8, 10, and 10. By doing that, you would have verified that this is the associative law. So basically that, for the second version of the law, it's not even complicated, it's the same principle, you're just replacing. Okay, so basically that. Now, the second version of the law just comes from the fact that this other one we're just adding. Okay, we're just adding like that. We were adding like this, and we have to find that the 6 is equals to 6. Now this is like when you're adding, this is like intersection, okay, in terms of sets. But when you're multiplying, it is like union. Okay, so if I've got, let's say, 1 times 2 times 3, is it equals to, if I say this time around I put the 1 then times 2 times 3, okay, am I going to get the same answer? Of course. 1 times 2 there is a 2 multiplied by 3, 2 multiplied by 3, that is a 6. When I come to the other side, 1 times, in the brackets we've got 2 multiplied by 3, that will give us a 6. Okay, then 1 multiplied by 6 is 6. So I'm able to see that whether I use multiplication or addition, I'm getting the same answer. So in this case, the multiplication is like the union. Okay, so you can also get it like that. Basically that. This is algebra, normal algebra, where we're using plus, times, division. But when you come to sets, we are using operations such as the union, the intersection, and the union. Okay, so basically that. So that's why the second version of the law, you're able to see that one has the union, the other one has the intersection. Doesn't change anything. Okay, so same to the De Morgan's laws. So let's solve the De Morgan's laws here. So we're trying to prove A union B, then there's a complement there is equals to A complement intersection B complement. Okay, first you have to find what A union B is. Okay, and I think we've already found what A union B is. We have 1, 2, Okay, we've got 1 in A, we've got also 1 in B. Oh, we don't have 1 in B, but we have a 2 in B, we have a 3 in A, we have a 4 in both, we have a 6, we have 8, we have 10. Okay, hope I haven't missed any number. So basically this, then I'm supposed to find the complement of that. Now the complement of this set, it means we want everything that is not in this set. So if I'm going to compare it with the universal set, what are those elements that are not going to be found in this A union B? Okay, so basically there is, let's check here. We don't have a 5. Okay, so I'm going to put the 5, it's one of them. We don't have a 7, I'm going to put a 7. What else don't we have? We don't have a 9 here, so a 9. So this is what is going to be our A union B complement. I'm saying this is A union B complement. It is equals to that. So we solved the left hand side. Let's come to the right hand side. We're supposed to find what A complement is, okay, and what B complement is, and we find the intersection between the two. So A complement, those elements that are not found or that are not in A. Okay, so in this case A complement, we've got A, we've got 1, okay, but its complement, we are going to have a 2 there, we're going to have a 5, we're going to have a 7, we're going to have an 8, 9, and I think a 10 there. Okay, like that. Oh, actually I've written on B, unfortunately. Okay, so we're saying we're going to have A complement, we're going to have a 2, we're going to have a 5, 7, 8, 9, and 10. When I come to B complement, okay, those ones that are not found in B, so our B is here, 2, 4, 6, 8, and 10. So it means B, which elements are not going to be found in B? We've got 1, we've got 3, we've got 5, we've got 7, and we've got a 9. Okay, then we're supposed to find the intersection between the two. Okay, so in this case A complement intersection B complement will be equals to, so just have to now start checking. Here we've got okay, we've got a 5 in A complement, we've got a 5 also in B complement, we've got a 7, we've got a 7, we've got a 9, and we've got a 9. So in this case we're going to have 5, 7, and 9. That is the intersection between the two sets. So in this case this is our right hand side. Now able to see that your left hand side and your right hand side, they are equal. Okay, why? Because here we have a 5, there we have a 5 as well. 7, 7, 9, and 9. Hence we've proven. Okay, hence proven. Okay, so basically that. Then the second version of the law is still the same thing. Okay, so basically that is how we go about this type of equation. Then given that the universal set is the set of all real numbers, use the sets A is equals to that and B is equals to that to verify the De Morgan's laws. Okay, so basically they haven't given us, they've told us the universal set is a set of all real numbers. Okay, so since all real numbers exist in this case, and they've given us that A is equals to negative infinity to 2 union, then we've got a 3 there, 9. Okay, closed intervals. Then we've got B, we are saying it's an open, it's a closed open interval. Okay, negative 7 to 2. So we need to verify the De Morgan's laws. So now you know the De Morgan's laws, we're just from solving the previous question. If I've got A union B, I have a complement, it's going to distribute inside. I'm going to have A complement. The operation is going to change. I've got union here, it's going to be intersection. Then I'm going to have B complement. Okay, so you can choose any of the two laws. Okay, so basically but for me I'm just going to go with this same law. We're still going to get the same final answer. Okay, so in this case, let's find out what A is. Okay, let's say if we've got on the number line, use the set. Okay, on the number line, if let's say this is a number line, so you can solve this question in different ways. It doesn't really matter. If I've got A, now A is from negative infinity. Let's put the infinity here, negative infinity, positive infinity. Okay, A is from negative infinity. We don't know where negative infinity ends until it reaches 2. Okay, that is A. We've reached 2. Then after I reach 2, 2 is not included. I'm going to open. Okay, and then another set is from 3 to 9. Okay, let's say that is from 3 to 9. So 3, I can put 3 is included and 9 is included. So basically this. So that is set A. Okay, then set B, it is from negative 7. If I put negative 7 here to positive infinity, so B is going all the way to positive infinity, and the negative 7 there is included. That is B. Now for A, we're trying to find its complement, and for B we're also trying to find its complement. Okay, but first of all, let's unite the two, then find their complement. If we're going to unite A and B, what are we going to get? A union B, what is it going to give us? So A is starting from negative infinity. It passes through 2, but there's also other parts of B. So able to see that if we're going to combine the two sets, we're literally getting all the numbers. Okay, all the numbers. So A union B alone, okay, it is giving us all real numbers. Okay, all real numbers. Now if it's giving us all real numbers, then there's a complement there. It means we're trying to find the complement of all real numbers, which it doesn't exist. Okay, in this case it is going to be an empty set. Okay, so here we have an empty set. Then let's come to the other side. We're trying to find A complement and B complement, their intersection. Okay, if I'm going to start with A complement, 2 is part of A, so it's not going to be part of 2 is not part of A, so it's going to be part of the complement. Then 3 is part of A, so it's not going to be part of the complement. So that is one area of A complement. Then another area is from negative 9 there, actually 10, then going all the way like that. So that is A complement. Then what about B complement? B complement is here, and we're going all the way in this direction. Now this question is asking us to find the intersection between the two. Okay, this is the intersection there. Now if you're going to look at this there is no intersection between B going this side and A. It has started from here, it has reached here, and it continues from here and goes all the way this side. So there is no intersection between the two. So able to see that even the other side is also giving us an empty set. So basically by doing that, you would have proven that, or you'd have verified the De Morgan's laws. So you're just going to write hence verified. Okay, so you can also try to use the other version of the law. You're still going to get the same answer. So all these videos, we've also done videos on the De Morgan's laws. You can also try to check out our videos. Then you can also try to check out the tutorial sheet we solved for 2025. So these concepts are just repeated. Yeah. Then we come to question number 4. We are told to let x to be negative 20 to 20, And then we're given that A is that, B is that, and C is that. Then we're told to find each of the following sets and display it on the number line. Okay, so what do we now do? So let's say A we've been given is C minus C. B, C we are given that it is 3 to 14. Okay, it's an open closed interval. Then B, it is negative 8, 4 union. Then we've got 8 and 9. Okay, so in this case, what are we now going to do? So this one we have to be very, very careful. Okay, so in this case, we're trying to find each of the solid and display it on the number line. Okay, so what are we going to do? So C, if you're going to look at C starts at 3, and 3 is not included, to 14. B is negative 8 to 4, which overlaps with C at a certain point. Okay, now B also has 8 and 9. Now these ones are going to be in C, so we're supposed to remove them. So for us to solve this one, let me just draw a number line. You see what I'm talking about. So if this is our number line, okay, and we just now show what these ones are. Let's say this is negative 8. Okay, which other number do we have here? We've got, let's say, okay, let's put a 0 here. Then the other numbers are positive numbers. We've got a 3, we've got a 4, we've got an 8, we've got a 9, we've got 14. Mind you, I've not put them, I've not written these numbers according to scale. I've just put for the sake of this question. Okay, so basically that. Then A or C actually is from 3 to 14, so this going all the way to 14. Now 14, if you're going to look at 14 is closed, so I'm going to shade there. Okay, but 3 is open, so I'm going to open there. Okay, that is our C. Then our B, we are saying we're moving from negative 8, okay, negative 8 all the way to 4. I join this one. Then there's another union. We are uniting it with a point 8 and another point 9. Okay, so basically those ones. Then we're trying to find what are we? This is B. Okay, now we're trying to find which question are we solving? C minus C, B. Now what this means is that from C we should remove B. Okay, now which parts overlap? So this part overlaps, we have to remove it, and also this other part, these 2 points are overlapping, we have to remove them. Okay, so in this case, what now remains is what we are going to write. So able to see that we've remained from 4 to 8. Okay, then we've removed 8 and 9. Then the other part that has remained is from 9 to 14, and that is our solution. So now how am I going to write it? Allow me to just rub this part. Okay, allow me to rub this part. Okay, so we're removing B, this part, that point, and that point. Then what remains is our final answer. What has remained? It is 4. Okay, now 4 is part of B. Because 4 is part of B, it's not going to be part of it's not going to be part of C. Okay, because it's part of B and we're trying to remove B. So in this case it will be 4. I'm going to open, then we are going to reach at 8. We are removing it, it's a point in B. Okay, I'm going to close there. Union, we're going to start at this same 8, but this 8 is because it's not included. I'm going to put 8 comma Also the 9 is not included. I'm going to put 9 union. Then 9 until to 14 also is not included. Okay, 14 is actually included because 14 is part of C, but it's not part of B. Okay, so I'm going to close there. So basically this is our final answer for this one. Okay, so let's solve the second one. It's not very different, I think, from what we're just from solving. Basically it's just about us. We've got B minus A, then we've got intersection C. So we're trying to remove those, so we're just supposed to use the number line as well. It will help so much. So let's say this is our number line. A, you're trying to B minus A. Okay, A is from -2 to 7, and both of them are not included, so I'm going to open. Okay, that is our A. And then B, okay, B, this is, let's say -8 is there, let's say 4 is here, let's say 8 is there, and 9 is there. So in this case, what are we going to do? We are saying we are moving from -8 to 4. Okay, -8 to 4, and these ones are included. Okay, I'm going to shade them. And then the other part of B, we've got 8 and 9. Okay, so basically that. And then we're trying to find, we're trying to remove A from B. Okay, so the only part of that we can remove for A is that part. Okay, so then what is going to be remain out of B? But of course, let's also write C. C, because we're trying to find also the intersection with C. C, it is from 3. If I put a 3 here to 14, let's say I put 14 somewhere there. Okay, so 3, we're saying from 3 is not included all the way to 14, and 14 is included, and we're trying to find the intersection. So let's start with the first one, B minus A. Okay, so this is our B here. We remove A, and when we remove A, what then remains is that we only have from -8 to -2. Okay, then we've remained with 8 and 9 there. Okay, so that is what we've remained with. Now we're trying to intersect it with C. Okay, and C, it is from 3 there all the way to 14. Okay, so the only part, because we've removed this part for A, it's not there. Okay, so the only part, because B now is starting from here after we've removed A, so the only part that where we're going to have B, the intersection between both of them, it's only these 2 points. Okay, so those are the only parts that are going to be found in both sets. So it's B minus A intersection C will just be equals to 8, 9. Then you put your braces. Okay, so basically that will be our solution. So all these questions, that's how you just solve them. There is no gist. So that's how you solve questions on the number line. Likewise, you can also watch our videos to understand this part of questions. Now let's solve question number 5. We are told that given that x and y are sets, simplify as far as possible each of the following. Okay, Now we've got the first one, it is x complement union y minus x, complement outside there. Now you have to recall that you can solve these questions whichever way you want. Okay, now we're trying to find the union of x complement with something that is how can I explain this one? If we're going to find let's first if this is x complement union, I solve what is in the brackets to be y intersection x complement. Okay, we know that this is called the difference law, okay, or a relative complement if you want. Then don't forget we have a complement outside. Now there's something that you're supposed to know here. Every time we've got this is called the absorption law. So the absorption law, it's a law, you just have to know it. Okay, if I've got let's say I've got x union, let's say y intersection x, okay, the answer that I'm just going to have is x. Okay, it is also true if let's say this time around this is x, this is y. Okay, then I've got a y there. Okay, what am I writing? Okay, so basically if you've got a letter and the same letter again is repeating, then you have union and intersection. That is going to be the absorption law. Okay, so basically that. So in this case, what do we now do? Okay, so in this case I'm just going to say this, what I'm going to have is, since we have the x complement, we're also going to have just x complement if we solve this set. Okay, but don't forget you have a complement outside, you're just going to put the complement there and you're just going to have x like that. Okay, of course not very complicated, you can go that way. Okay, so the union of x complement with something inside x is just x complement. That is what you should know. Now if you got y intersection x complement, that will just be a subset of x complement. That's why we are just getting the x complement like that. That's what this expression just tries to talk about. Then let's solve b. Okay, so b is the same law again. We have y and we have y, then we have union and intersection. Okay, so basically you're able to see that it's the same absorption law. Okay, so the union of y with a subset of y is y. Okay, so basically that. So in this case, what are we going to have? So the simplest way I'm talking about is the union of y with a subset of y is y itself. Okay, so because we're trying to find the intersection between x and y, in as much as we're going to find that intersection, then we're uniting it with y, we're still going to have y, right? That's the absorption law, it just absorbs itself. So this is also y there. Then we come to c. So we've got x complement union y intersection x, then we have a complement outside. Okay, is this the same law? Okay, so this is rather a bit different. So here we have to be very, very careful. So let me distribute the complement first. Okay, so notice the difference. This is x complement, this is x. It can't work, the absorption law can't work, so you have to be very careful. there, okay, unless if these ones were the same, okay. So here we're just going to now just solve it in a normal way. So I'm going to have x, this is a complement, I'm going to distribute the complement, then the union is going to become intersection, then I'm going to have y intersection x, then I'm going to put a complement there, okay. Then I solve x complement, x complement, x complement, and the complement will just give me x intersection. Now there are different ways on when you reach here. You can solve it in any way that you want. In this case, I'm just going to distribute the complement inside the bracket. So I'm going to have y complement union, okay, union x complement, okay. That is what I have. Now you know something about what we call the distributive law. The x intersection is going to get with that one. Again, the x intersection is going to also multiply with the x complement there. So in this case, we're now going to have what? I'm going to have x intersection y complement. I put this in bracket union. I'm going to have x intersection x complement. Okay, so basically that. Now someone would ask, what is the intersection between x and its complement? Basically you're not going to find anything there, okay. So if I've got, this is our x, this is x, then we're trying to find it with the intersection with its complement, which is outside. So there's nothing common between what you have inside x and what is outside x, so it's just an empty set. So in this case, what are we going to have? I'm going to have x intersection y complement intersection or union. Actually there's a union there, union empty set. Now even if you unite this with an empty set, you're just going to have x intersection y complement, okay. Basically that, because you're adding something with nothing, you're going to have something, okay. So basically that is how you solve that one. Let's solve the other one. So we are solving which one? Okay, we are solving D. Actually we've got x intersection y union x intersection y, then there's a complement there. So what do we do? So in this case, I'm going to factorize the x intersection to bring it back to the way it was. So I'm going to have x intersection, then I'm going to remain with a y there, then I've got a union there, I'm going to put the union there, then I've got a y complement there, a y complement, okay. Basically this. Now I'm going to have x intersection. I try to solve what I have in the bracket. Now if I combine y and its complement, what do I have? This is y, let's say this is y, inside that is y, then y complement will be everything that is outside. Then we're trying to find the union, so able to see that we're just going to have the whole total set, which is the universal set, okay. So in this case I'm going to have the universal set. Now the question would be, what is the intersection between x and the universal set? Okay, if this was now, let's say this now, instead of y is x, we're trying to find the intersection between x and the universal set. We're just going to have x, right? So in this case this will be x. So this is how you simplify sets as far as possible. Then we come to question number 6. Now on question number 6 we're told that in a single Venn diagram, illustrate the relationship between the sets of natural numbers, integers, rational numbers, irrational numbers, and real numbers. Let's start with natural numbers. Now if you're going to talk about natural numbers, these ones are positive integers, okay. So of course you're starting from 1, 2, 3, and you're going like that. Those are natural numbers. Then if you're going to talk about integers integers, we're talking about the negatives. If I'm going to have -2, -1, 0, and the positive numbers, +1, +2, and like that. Okay, those are integers. And then when we're talking about rational numbers are those numbers. Okay, rational numbers is the symbol there is Q. Okay, looks like a Q actually, it's not even Q. So all numbers that can be written in the form of A over B, where your A, your B, these ones are members of integers, and your B should not be equals to 0. Why? Because when B becomes 0 here, it becomes, the function becomes undefined. Okay, so this includes all integers. So basically that. Then yeah, like that. Okay, so it's very important. Fractions, okay, in simpler terms. Then we've got do we have real numbers here? Okay, yes, real numbers. First, before we talk about real numbers, they're what we call irrational numbers. Okay, irrational. Okay, irrational numbers, in simpler terms, we're talking about you know, they disjoint from the rational numbers. Okay, they cannot be expressed in this form. So we've got numbers like the square root of 2, pi. Why? Because they give non-repeating decimals. Okay, so you're going to find that maybe you've divided a number, but it's giving you, you know, there's no pattern, and it's going like that. It's going, let's say there's 3 again, it's going in this direction, it's never ending. Okay, and there's no pattern there. Those will be irrational numbers. Okay, then real numbers, we include all these numbers we've talked about here. Okay, except the last part of numbers, which we call complex numbers. Okay, since here there are no complex numbers, those are the big numbers. So now we're taught to draw in a single Venn diagram. Okay, so let's now draw. We're starting from the largest, or let's start with the smallest set first. So the smallest among those ones will be natural numbers. Okay, because we only have one going all the way to wherever you're going to end. Then from rational numbers, we're going to move to integers, because integers, they do not only include 1 to like wherever you're going to, like even infinity, positive infinity. Integers are also going to have negative numbers. So I'm going to put Z there for integers. Then from there, you're going to go to you're going to go to the other set of numbers, which we are calling rational numbers. Okay, which I'm just going to abbreviate as something that looks like a Q. Then from rational numbers, I'm now going to have irrational numbers. Big numbers like pi, the square root of 2. Okay, so I can just put irrational numbers there. Then the last type of numbers from the list they've given us will be real numbers. I'm just going to put an R there. So this is, you know, the single Venn diagram. Since they want a single Venn diagram, put also the barricades nicely like that to show that this is a Venn diagram and that is the universal set. So basically that's how you solve these types of questions. Then we've gone to question number 7. So these are rational numbers, they are fractions. If I've got a number, let's say 1 over 2, this will give me 0.5, right? Then what number is going to be repeating? 0, 0, 0, 0. So I can put even a bar there to represent that that 0 is repeating. A good example again is 1 over 3. This will give us 0.3333. Instead of us writing 3's throughout, we can even put a bar where 3 is repeating. Okay, where 3 is repeating, that's where these numbers are coming from. So now they're asking us to express each of them in the form A over B. A over B is a fraction. They want us to take them back to the way they were as the fractions and give your fraction in its lowest terms. Okay, so basically this, so we've got 80.12 and we've got those, you know, two numbers repeating. So in this case, I'm going to let the whole expression Okay. I'm going to let 8.12 repeating to be equals to x. Okay, or I'm going to say yes, since x is that, so x is equals to 8.12 repeating. Then what I'm now going to do is that I'm going to multiply, since we've got two numbers that are repeating, I'm going to multiply by 100, okay, on both sides. So when I multiply x with 100, I'm going to have 100x this side. When I multiply it with this other one, 8.12 repeating, I'm going to have 812.12 repeating. Okay, then what I'm supposed to do is that I can name my equation. This one is equation number 2. Okay, let me say this is equation number 2, this is equation number 1. Then what I'm going to do, I'm going to subtract equation number 2 minus equation number 1. Then I solve. So in this case, if I subtract 100x minus x, I'm going to have 99x. This would be equals to, then I come to the other side, repeating and repeating, they're going to give us a 0. So in this case, from this number 812, I'm subtracting an 8. Okay, what am I going to like have? Is it 80? Is it what? 8 what? 804? Let me just, okay, 804. Then I divide by 99 on both sides. Okay, so our x will just be, then from there you try now to, if there's any number that can go into both of these numbers, you simplify it as low as you can. So since I don't have a calculator, you can try that, okay, or try to punch this number if it's going to give you that one. Okay, so basically this is how we solve this one. Okay, not very complicated. Then there's also another one. We can also solve this other one. We can solve b. Now b is not very different. Okay, actually it's even different. Negative 4.314. 14 is the one that is repeating. So the clue that I'm going to give you, since the point is here, you would want it to move first one step before it moves the final step. Okay, it moves there. Then after it has moved there, then now it jumps these two decimal places. So in this case, I'm going to multiply by 10 first so that the point moves there. Okay, so I'm going to have this side, I'm going to have 10x, okay, will be equals to negative 43.14 repeating. Okay, then now what I'm going to now do, I'm going to again multiply. Now this time I'm going to multiply by now the 100, because the point is very close to the number that is repeating. It's possible. So this side I'm going to have 1000x, okay, because I've multiplied by the 100. I'm multiplying the 100 on both sides. So this side I'm going to have negative 4314.14 repeating. Okay, then what I'm supposed to do is just to subtract equation number 2 minus equation number 1 in this case. So here I have 10,000 minus 9 minus 100. No, 1000 minus 10, that will give us like 990x. This will be equals to, then you subtract this. Okay, so what are you going to get if you subtract that? Yeah, so we've got 4314. Okay, then you subtract by 43. Okay, so that is like 1, that is like 2, 11 minus 4, well, 11 minus 4, that is like is it 7? Then we've got a 2 there, we've got a 4, so we're going to have like negative 4271. Hope we're very correct. Then we divide by 990 on both sides. Okay, so you can either leave it here, but they've said give your fraction in its lowest terms, so you should always be looking for a number that can go into both there. So let's try a 3. I'm going to have negative 3. I'm going to have negative 3 into 4, that is a 1, remainder 1. 3 into 12, I think that is a 4. 3 into 7, that is a 2. So 3 can't even go there. Okay, so basically you can even leave it there, or you can also try 9 if 9 can go into, you know, both of these numbers. So basically that is how you're going to go for this one. Then let's say another one is which one? We're trying to look for something that is a bit strange. Okay, we're going to go for 7.1222 repeating. I'm not going to write all those tools. I'm just going to put a repeating bar there. Okay, so this we can say x. Let's say x equals to that. Then I'm going to just multiply by 10 on both sides, because first I want the point to move there, to move close to the number that is repeating. Then now I multiply again by 10. So here I'm just going to multiply by a 10 first. I'm going to have 10x is equals to 1.2 repeating. Then from there I'm going to again multiply by 10, because now I want to move the point for the final step. So I'm going to have 100x this side, which is equals to 712.2 repeating. Now that I've got this, I'm just supposed to now subtract. This is equation number 1, this is equation number 2. Equation number 2 minus equation number 1. 100x minus 10x, I'm going to have 90x. This will be equals to 712 minus 71. Okay, so if I've got 712 minus 71, okay, 2 minus 1, that is a 1. I'm going to have a 6 there. 11 minus 7, that is a 4. 641. Then I divide by 90 on both sides. Okay, like that. Then our x therefore will just be equals to, then if there's any number that can go into both, you can try it and you simplify it further. Okay, like I've said, I don't have a calculator, but it's still not even complicated. If there's no number that can go into that, then it's fine, it's still a fraction. Okay, so basically that. The way you easily confirm that it is the answer, always get this same answer, no matter how big it is, punch it on the calculator, it should give you that answer. However, you're not allowed to use the calculator in the exam. They're going to bring just things that are very, very simple, that you can just you know, not really like big figures. They might be big figures, but they'll not chew much of your time. Okay, so we come to question number 8. Now express each of the following complex numbers in the form a plus bi, where a and b are real numbers. Okay, so this is an interesting question. Now we've transitioned to us expressing in a and ib or bi. These are what we call complex numbers. Okay, so let's review complex numbers. So if you haven't learned complex numbers, please, you can also watch any of our videos on complex numbers. You're going to find it. Not very complicated topic. Okay, so here now, what you have as I, wherever you're seeing I, this is just the image. Okay, because the complex number is in the form of a plus ib. A is the real part, ib is the image, okay, of the same a. So basically that. So now let's solve this one. Okay, so this is just a normal quadratic expression. 2, if you want, you can just solve them. 1 minus 4i, then you solve it like that. Okay, but quickly, if you want to solve things quickly, get the first one, square it. Okay, I'm going to have 1, square it. Then I'm going to get the 2, I'm going to multiply it with 1. The answer I'm going to get again, I'm going to multiply it with negative 4i. That's the middle number that I'm going to put. 2 multiplied by 1, it's a 2. Okay, that 2 multiplied by negative 4i, I'm going to have what? Negative 8i, right? Oh yes, negative 8i. Then the first one I had to square it, and now to find us the last one, I'm supposed to square the last one as well, which is 4i. Now when I square 4i, then I square it, what do I have? So 4 plus 4, okay, 4 squared, actually that is 16. Okay, then I'm going to have I squared. Okay, basically that. So let me just rub this part, I write it nicely. We're going to have 16 I squared. Okay, now that we've got this, I can now simplify. 1 squared is just 1 minus 8i. Then I squared is equals to a negative 1. Okay, so if I squared is equals to negative 1 multiplied by this 16, it will give me negative 16. Then I solve. In this case, I'm going to put the numbers together and the image alone. Now I've got 1 minus 16. I'm going to have negative 15 minus 8i. Okay, so this will be my final answer. I've got the real part and I've got the image part. Okay, so basically that is the form they want. They want it in the form of a plus bi or ib. Okay, so basically that's how we solve the first question. Let's go to B. For B, we've got 4 minus I, 2 plus 3i. Okay, so what are we going to do? We're just distributing here, nothing complicated. The 4 multiply with everything that is in the bracket, we find the answer. Then the negative I multiplies with everything that is in the bracket, we find the answer, and we solve using like terms. So 4 multiplied by 2, I'm going to have 8 there. Then the 4 multiplied by the 3i there, I'm just going to have plus 12i. Then I come to the negative I. Negative I multiplied by 2, I'm going to have negative 2i. Then negative I multiplied by positive 3i, I'm going to have negative 3i squared. Please, the I, don't make a mistake. Okay, that's where most students tend to make mistakes. Therefore, I'm going to have 8 here. 12i minus 2i, that will give me positive 10i. Okay, then I've got a negative here. I squared, we've said is negative. Okay, negative and the negative give us a positive. Therefore, I'm just going to have a 3 there. Then I'm supposed to solve the like terms together. This is 8 plus a 3 there. What does it give me? It gives me 11. Okay, plus 10i. When we've done that, we've solved. Okay, it is in the form of a, which is the real part, and bi or ib, the image, which is this. So basically that is how you solve this one. Okay, we come to C. Okay, C is rather different, so we have to solve it. So we've got 1 minus 2i 3 to the power 3. Okay, so what are we going to do? So if you to be smart enough, you don't want to put a lot of them like that. That will be so burdensome. So start first with the first 2. Then after I find the answer, that answer now multiply with the other one. Okay, that will be easier. So in this case, I'm going to have I minus 2i. Let me first start with a square, the one that is squared. Okay, so in this case, what am I going to have? When I square the 1, I'm going to have 1 squared, which is just a 1. Okay, then when I multiply 2 multiplied by 1, that is a 2. A 2 multiplied by the negative 2i, I'm just going to have negative 4i. Okay, negative 4i squared, actually. No, actually negative 4i, just like that. Okay, because we are literally multiplying. Then the last part, I'm supposed now to square the negative 2i. Okay, this is where I'm going to have, if I square negative 2, I'm going to have positive 4. Okay, then I've got I squared. So basically that. Then when I solve this, what do I have? I've got 1 minus 4i. Now I squared, we've said, gives us a negative, so I'm going to have negative 4. Okay, now 1 minus 4, what does it give me? It gives me a negative 3. So I'm going to have negative 3 minus 4i. This is what I have. Then I'm supposed to multiply it with one of these ones, because we've left 1 there, right? So basically that. So I'm going to get my answer. I'm going to write it on top, negative 3i, negative 3 minus 4i. Then I multiply with 1 minus 2i, the one that remained. Okay, then from there I solve. Okay, so when I solve this one, I'm just distributing negative 3 into everything that is in the brackets. I'm going to have negative 3 plus 6i. Okay, then when I come to negative 4i, when it multiplies with that, I'm going to have negative 4i. Then negative 4 multiplied by negative 2, I'm going to have positive 8. Then I multiplied by I, I'm going to have I squared. Okay, I'm very careful on the I, because if you make a mistake there, your answers are going to be very wrong. Okay, so now I'm going to have negative 3i. I've got 6i minus 4i. What does that give me? It's going to give me positive 2i. Okay, then we've got I squared. I squared, we say it's negative 1. So negative 1 multiplied by the 8 that it is attached to, I'm going to have negative 8. Then now I solve negative 3 minus 8. That will give me a negative number, negative 11 plus 2i. So this will be my final answer. Okay, so basically that. So these questions are not very hard to solve. Which other one can we solve? Let's solve d2 minus I to the power 4. Okay, so of course you just start with one of them, 2 minus I. Okay, solve the squared first. Okay, if we solve the squared for this one, what is it going to be? If I square 2, I'm going to have 4. 2 multiplied by this 2, it is 4, multiplied by the negative I, I'm going to have negative 4i. Then when I square the I, what am I going to have? I'm going to have I squared. Okay, I'm going to have I squared. Okay, I squared. So we've got a negative there. Okay, so we're going to have plus I squared. Now I squared, we're saying I squared is just a negative number. Okay, so in this case, what then do we have? So we're going to have 4 minus 4i. Then we've got I squared, which is negative 1. I'm going to put negative 1 there. Then 4 minus 1, that is a 3 minus 4i. So we found 4 when it's squared. So because it's squared, we're going to now get this one and square it again. Okay, to find us the last part, because it's to the power 4. Okay, so we're going to have 3 minus 4i. Then you square this part. Okay, so what do we now do? In this case, it's the same thing. When I square 3, I'm going to have 9. Then I'm going to multiply 2 multiplied by 3, that is a 6. Then a 6 multiplied by negative 4i, I'm going to have negative 24i. Okay, then I square the last part, which is negative 4i. When I square 4, I'm going to have 16. When I square I, I'm going to have I squared there. Okay, I'm going to have I squared. Okay, oh, actually I've made a mistake. When I square negative 4, I'm going to have positive 16 actually there. So we have to be very careful there. Then what do we now do? I'm going to have 9 minus 24i. Then because we've got I squared there, it's multiplying with 16, we're going to have negative 16. Now that we've got this, 9 minus 16, what does it give me? 9 minus 16 gives me negative 7 minus 24i. So this is our final answer. Okay, so that is it. That is D. Okay, let's now solve E. E, we've got 1 plus the square root of 2i, okay, over the square root of 8 minus, okay, the minus 3i. Okay, first you have to first know that in the denominator we've got the square root of 8 there. You can simplify this one, okay, to the square root of which two numbers can we get, you know, to just simplify this surd. Now you're always going for perfect squares. Perfect squares are those numbers, all the numbers from 1 to 10. If I square them, the answers I'm going to get are perfect squares. So I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let me say 10 or even 10. I end at 10. If I square all these numbers, okay, the answers I'm going to be getting are what we are calling perfect squares. So 1 squared is 1, 2 squared, that is a 4, 9, 16, 25, 6, that is 36, 49, 64, is it 81, and is it 100, that is like 100, somewhere that. So you're always going for these numbers, okay? You want when you get your number and you put it in this root, it gives you a simplified answer. So like for 8, which numbers can we break it into so that it gives us a perfect square or a perfect number? Okay, so you're going to need a 4 and a 2. Okay, so I'm going to put 2 multiplied by 4. Then, according to your rule of surds, I'm going to have the square root of 2 multiplied by the square root of 4. Now the square root of 4 is what you're interested in, which is 2. Then we've got the square root of 2. That is what 8 is going to give us there. So I'm going to just write that in advance. I'm going to have 1 plus 2i over 2 root 2 minus 3i. Okay, now that we've got this, what we're now going to do is that we're supposed to now do to multiply the numerator and the denominator by the conjugate. The conjugate is the opposite of what we have down there. Okay, so basically that. So I'm just going to do it in a different fashion. So since this is the one that we have is a minus, okay, and if we square that, because what is going to happen is that look at this. So we're multiplying by 2 root 2 minus 3i on the denominator. Then on the numerator we've got 2 as well, root 2, actually it's plus 3i. Okay, plus, that's the opposite of this one. Okay, so basically this. Now you remember from your difference of two squares, if I've got a minus b, then I've got a square outside. This is also the same as a minus b or a plus b, right? That was the difference of two squares. It's not very different from this one. Okay, so basically that's what we are going to do to the denominator, but to the numerator we have to just completely solve. Okay, so in this case, what am I going to do? I'm multiplying the top part and that. Let's start with 1. When 1 multiplies with the other part, I'm just going to have 2 root 2 plus 3i. Now it's the 2i multiplying with that other part. So here, that's where I need to be very, very careful. Okay, here you have to be very, very careful. So we've got 2i. Where is the question? Yeah, 2i multiplying by actually it's not 2i, 2 root I. So guys, there's a root here, I forgot. So it's 2 root, there's a root there. Okay, So we are multiplying root 2I multiplied by 2 root 2. Okay, so here we have to be very careful. So what is going to happen is that what have we written so far first? Okay, so we've got a root and another root. Okay, those ones are going to cancel. Okay, and what it means according to the rule of SURDS, so you can also watch our videos on SURDS. You can just type Novastone SURDS, you're going to find it. If I've got 2 and it's multiplying by, if we've got root 2 and root 2, they're multiplying by themselves, the root and the root are going to cancel. I'm just going to have 1 2. Okay, or the other version, or the way you can also solve this is because they are multiplying, I can write it as 2 squared, and the square and the root are going to cancel. I'm just going to remain with 2. Okay, so that's what is going to happen for those ones under a root. So I've got 2 under a root and I've got 2 under a root. Those ones will give me a 2. Okay, then don't forget you have another 2 here. So it means the 2 that you've gotten is going to multiply with this 2 to give us a 4. Don't forget you have an I there, so we're going to have 4I. Okay, now what symbol are we going to use? Since everything is positive on top, we're going to have positive. Let me use my usual color. I'm going to have positive 4I. Okay, now that we've done that, we're going to multiply root 2I multiplied by 3I on the other side. Okay, so what am I going to have? I'm going to have plus 3, then there's I'm going to have root 2I squared, because the i's are 2 of them. Okay, so basically that. Then down, like I said, down I'm going to use the difference of 2 squares. But before we do that, let's first finish up with what we have on top. Now if we simplify what we have on top, what then do we then have? Okay, so 2I, we've got 2 root okay, I'm trying to look at this, how we can simplify it further. Is there anything that we can cancel here? Okay, we've got 3I plus 4I there. Okay, so we can also simplify that one. So we've got 2 root 2, then there's 3I plus 4I there. We're going to have plus 7I. Okay, then plus 3 root 2, then there's I squared. Okay, then what do we now have as at this point? Allow me to solve what I have this side. This side I've got 2 root 2 minus 3I. Okay, I'm saying I'm going to use the difference of 2 squares there. Okay, now when I use the difference of 2 squares here, what then will be my answer? Okay, so I'm going to have when I square root the 2, I'm going to have a 4. Okay, then when I square root this is root 2, I'm just going to have a 2 there, because the root and the square are going to cancel, minus, then when I square root the 3, I'm going to have 9. When I square root the I, it's going to be I squared. Now I squared is negative 1, which is going to multiply with the 9 is going to give us a positive there. Then 4 multiplied by 2, that is 8. The 8 plus the 9, that will give me what? 8 plus 9, that gives me what? A 17. Okay, so the denominator automatically is going to be a 17. We've just calculated that, so I've just done that because of space. Okay, so we're going to carry the denominator throughout. Okay, so then what do we now do from here? I'm trying to look at what we can simplify to be something small. Okay, what can we how can we simplify this one? I don't know if it's already simplified, or if we can leave it there where it is, or if we can leave it there where it is. Okay, let's try to do something here. Okay, we've got 2 root 2 okay, so we can simplify this one. That is I squared. I squared is it gives us a -1, right? And when a -1 multiplies with everything there, it's just going to give us, so we're going to have 2 root 2 plus, okay, allow me to write it just on the other side. We already solved this part. Okay, so this question is very interesting. We are going to have 2 root 2. Now I'm solving this part. This is a -1. I squared is a -1. It's going to multiply with the 3 in front. Okay, the -1 is going to multiply with the 3 in front. So I'm going to have -3 root 2 plus 7i. Okay, then we've got a 17 down. Then we've got, what this means, these are like terms. Okay, there's a root 2 there, there's a root 2. I've got a number there, I've got a number there. So these ones are going to, they're going to we're supposed to add, to subtract them. So in this case, we've got 2 minus 3. Okay, that will give us a -1. Then we've got a root 2. Okay, so I'm just going to say -root 2. Okay, plus 7i over 17. Okay, so basically this is what we have. Now to simplify it further, because you know that it's supposed to be in the form of a plus ib, you can't leave it there. The final one will be -root 2 over 7 plus 7 over 17, then the I there. You would have shown it in this, in this form. So basically that is how you solve this one. Not very complicated. Okay, so like that. Okay, so let's solve question number 9. Okay, so simplify each of the following SURDS. Okay, so for SURDS, it's not very complicated. These ones are also called radicals. So let's start with the first one. We've got 2 minus 5 48 plus 4 root 75. Okay, now what do we do here? So I'm going to get the bigger numbers and I'm going to simplify them so that we just replace them in the actual equation. So one of the bigger numbers that we can get here is for the square root of 48. The square root of 48, I'm going to look for two numbers that I can multiply. Okay, like I've told you, you're always targeting perfect squares. So if I divide 2 into 48, that will give me 24. There's no 24 is not the perfect square, so I'm going to go to the next number, 3. If I divide 3 into that, I'm going to have 16. 16 is a perfect square, so I'm going to have 3 multiplied by 16. Okay, which can simplify to root 3 multiplied by root 16. The square root of 16, that is a 4. Okay, then root 3. This is a simplified version of the square root of 48. Then the square root of 75. Okay, we're also going to do the same. If I divide 2 there, 2 will give me a remainder. We don't want anything that gives a remainder. Let's say 3. 3 into 75. 3 into 75. 3 into 7, that is a 2. Remainder 1. 3 into 15, that is a 5. 5 is a perfect square, so we're also going to go for 3 and 5. And 25. It's what? 3 and 25. Okay, so now the square root of 25, it is a 5, then root 3. So these are the two, that we're going to replace there. So I'm going to now replace. I'm going to say 2 minus 5. Okay, 48, we found that So I'm going to multiply. There's 4. There's 4 actually, not 5. There's 4 root 3 plus 4. Then 75, we found that it is 5. Okay, so we're multiplying by 5 root 3. Then from here you just solve. We've got 2 minus, now I've got 5, negative 5 multiplied by this 4 will give us a negative 20. Okay, then negative 20 root 3. Okay, then plus 4 again multiplied by 5, that will give us a 20 root 3. Now able to see that negative 20 root 3 and positive 20 root 3, these are like terms. Okay, they'll give us a 0. So our answer here will just be a 2. So basically this is how you solve this one. Okay, let's solve also B. So for B we are given 4, 72 there, minus 7, there's 50 there, plus 2, 18. Okay, so what do we do here? I'm going to get all the bigger numbers. We've got 72 there, the root of 72. You start, if I divide 2 into 72, 2 into 7, that is a 3. Remainder 1. 3 into 12, 2 into 12, that is a 6. 6 is a perfect square. So we're going to go for 2 and 36. So 36 multiplied by 2. The square root of 36 is a 6. So I'm going to have 6 root 2. That is for 72. Then we come to the other big number, 50. The square root of 50. The square root of 50, two numbers. If I divide 50 divided by 2, that will give me a 25. 25 is a perfect square. So 25 multiplied by 2. The square root of 25 is 5. So I'm going to have 5 root 2. Then I come to the other one, 18. Okay, the square root of 18. Now, 2 into 18, that is 9. 9 is a perfect square, so 9 multiplied by 2. The square root of 9, that is a 3. Okay, then root 2. Those are the numbers we're going to replace in this equation. So I've got a 4. Where the 72, we're replacing 6 root 2 minus 7. Where there's a 50, we're replacing 5 root 2 plus 2. Where there's 18, we're replacing 3 root 2. Then we just simplify. 4 multiplied by 6. What does 4 give us? Multiplied by 6 gives us 24 root 2. Then minus 7 multiplied by 5, that is a 35. So 35 root 2 plus 2 multiplied by 6. 2 multiplied by 3, that is a 6 root 2. So now you're able to see that these are like terms. This has root 2, this has root 2, this has root 2. And in front we have numbers. So let's start with the numbers. We've got 24 minus 35, then plus 6. Okay, so that is how we are solving that one. Okay, so 24 minus 35, I think that is 11. 11 plus 6, that is negative 11. Negative 11 plus 6, that is negative 5, then root 2. So that is our final answer for this one. Okay, let's solve more questions. So just trying to solve all the concepts. Okay, so there are longer questions, I think, in this tutorial sheet. So we've got 8. There are longer questions in front. Okay, so that is C. Okay, so what are we going to do? Now I'm just going to be solving it directly. I've got 8 there. 32. We're supposed to look for two numbers. I think 16 and 2. 16 multiplied by 2, that will give us 32. 16, the square root of 16, it is just a 4. Okay, then I'm going to have root 2 there. Minus, I come to 3. I come to 18. 18, we said it is just 9 root it is just that is 18. That is, we said it is 3 root 2, okay, plus 2. Then for 98, we're going to look for two numbers. 2 into 98, that is 2 into 9, that is a 4. Remainder 1. 2 into 18, that is a 9. 49. 49 is a perfect square. Okay, the square root of 49, that is a 7. Okay, so I'm going to have a 7 root 2 there. Okay, then we just solve. 8 multiplied by 4, that will give us a 32. Okay, then root 2 minus 3 multiplied by 3, that is a 9 root 2 plus 2. 2 multiplied by 7 there, it is a 14 root 2. Since all of them have got root 2, we're just supposed to subtract and add. 32 minus 9 plus 14. That gives us something like 37. You can confirm root 2. Okay, so basically that is how we solve this one. Let's solve D. For D, we've got 6 minus 3, 108 plus 4 root 147. Okay, so the numbers now, they're becoming bigger and bigger. Okay, so the square root of 108. Okay, we're still going to use our same method. If I divide this by 2, 10 divided by 2, that is 5. 10 into 10 divided by 2, that is 5. 5, then 2 into 8, that is 4. 54 is not a perfect square. So I'm going to go for 3. 3 into 10, that is a 3. Then remainder 1. 3 into 18, that is a 6. 36 is a perfect square, so we're going to go for 3. Okay, now that 3 to be what? It will be the square root of the 6, that is 6. Then we're going to have root 3. That is for 108. Then for 147, okay, we're going to try. I think if you divide by 2, it will leave a remainder because we have a 7 at the end. So 3 into 14, that is a 4. Remainder 2. 3 into 27, that is a 9. Okay, so 49 is a perfect square. The square root of 49, it is a 7 root 3. Then now you just replace there. So we're going to have 6 minus 3. Okay, then 108, we said it is 6 root 3. Okay, plus. Then we've got a 4 there. 147, we said is 7 root 3. Then you just solve. We've got 6 minus 3 multiplied by 6, that is 18. Then I've got a root 3 there, plus 4 multiplied by 7, that is a 28. Then I've got a root 3 there. Now 6, I'm just supposed to now negative 18 plus 28. What is it going to give us? Okay, so 8 minus 8, that is a 0. Then 2 minus 1, that is a 10. Okay, so in this case we're going to have plus 10, the square root of 3. Why plus? Because 28 is bigger than 18 there. Okay, so basically this is our final answer for that. Let's solve E. So if you've reached this far, please don't forget to subscribe to our channel. Okay, you can also comment or also like this video. Okay, so we come to question number E. We're saying 7 plus 3, the square root of 192 minus 4, the square root of 75 minus 4, the square root of 27. Okay, so here what do we now do? I'm going to get the bigger numbers. 192. Okay, so we're going to use 3. 3 is the one that has been giving us bigger good numbers. So 3 into 19, 3 into 19, that is a 6. Remainder 1. 3 into 12, that is a 4. Okay, so able to see the square root of 64. There just gives us 8. Then root 3. Then we come to 75. 75. Okay, 2 can't go there, so 3. Okay, 3 3 into 75, that is like 25. Okay, 25, the square root of 25, it's 5, root 3. Then we come to the other one, 27. 3 again, 3 into 27, that is 9. Okay, so the square root of 9 is 3, root 3. So that is what we're going to go for. So we're just supposed to replace 7 plus 3. Where there is 192, we found that it is 8 root 3. Then minus 4. Where there is 75, we found that is 5 root 3. Then, which other parts? We've got negative 4. Where there is 27, we found that it is 3 root 3. Then you solve from there. Here, what do we now do? We've got 7 plus 3 multiplied by 8. That is a 24 root 3. Then negative 4 multiplied by 5, that is a 20 root 3. Then negative 4 multiplied by 3, that is negative 12 root 3. Okay, then you solve. 7 is going to be maintained. However, you're now going to add 24 minus 20, that is a 4. A 4 minus 12, that will give us negative 8. Okay, root 3. So this will be your final answer. Let's solve the last one, which looks, it has bigger numbers, but still nothing is complicated here. It's not very, very complicated. We are saying 4, the square root of 72 plus 2, 147 minus 4, the square root of 108 plus the square root of 192. Okay, so with our easier method, let's start with 72, the square root of 72. In this case, which two numbers? So we said if I divide 2 into 72, 2 into 7, that is 3. Then remember 1, 2 into 12, that is 6. That is 6. So that is like 36. 36, the square root of 36, that is 6 root 2. We come to 147, the square root of 147. 147, I think we had solved it in D. What did we find? Okay, we can't remember, but we can still, we'll still go because 7, we can't divide by 2, so we're going to go for 3. Because 7 there, it's going to leave a remainder. So 3 into 14, 3 into 14, that is like 4. Then remainder 2. Then 3 into 27, that is like 9. So 49, the square root of 49, that is a 7. Then we're going to have a root 3 there. Then we come to the square root of 108. Okay, 108. If we try 3 again, if we try 2, we said it is going to give us 54. 54 is not a perfect square. 3, if we say 3 into 10, that is a 3. Remainder 1. 3 into 18, that is 6. So the square root of 36, that is a 6 root 3. Then we come to 192. Okay, 192, we're going to try, let's say 2. 2 into 18, that is like 9. Then 2 into 2 into 2, that is 1. 91. 91 is not a perfect square. So we're going to go for 3. 3 into 19, that will give us a 6. Remainder 1. 3 into 12, that is a 64. Okay, the square root of 64, that is 8. So we're going to have 8 root, the same 3 we're dividing by. So basically, those are the things. Then we're just supposed to replace them. So I'm going to have 4 here. 72, that is 6 root 2 plus 2. 147, we said is 7 root 3. Then minus 4. 108, we said is 6 root 3. Then plus 109, we said it is 8 root 3. Then from there, you just solve this. So if I multiply 4 multiplied by 6, that is a 24 root 2 plus 2 multiplied by 7, that is a 14 root 3 minus 24 root 3 plus 8 root 3. Okay, So here what do we have? We're going to have 24 root 2. Okay, then these other ones have got root 3. So these ones you can simplify them. So we've got 14 minus 24. I think that will give us something like negative what? Negative 10. Yes, negative 10 plus 8. That will give us minus 2. Then we've got root 3. So basically that is how you solve these questions on SURDS. Not very complicated. We come to question number 10. We're taught to rationalize the denominator of each of the following expressions. Okay, so we've got 2 root 3 minus root 2 over 3 minus 2 root 12. Okay, so what are we supposed to do? We multiply by the conjugate. The conjugate, the opposite of what we have as a denominator, so that will be 3 plus 2 root 12. Then we're going to have 3 plus 2 root 12. Okay, now we're just supposed to multiply what we have on top. Okay, so I'm going to multiply these ones on top. Okay, so what do we have when we multiply on top? Okay, so for the numerator, 2 root 3 multiplied by 3. Okay, I'm just going to have 6 root 3. Then I have 2 root 3 multiplied by 2 root 12. Okay, here I'm supposed to be very, very extra careful. Okay, so what are we then going to have? So I'm going to have 2 multiplied by 2, 12. Can we simplify 12? Is it possible? Yes, we can simplify 12 actually. Okay, so for 12 it's going to be the square root of 12 is that to be 4 multiplied by 3, right? Then the square root of 4, that is 2, then root 3. Then don't forget this 12 has a 2 in front, so the 2 and the 2 are going to multiply, they'll give us a 4. Okay, so that will be 4 root 3. Okay, okay, so 4 root 3 there, so I can just replace it in advance. Okay, I can replace this one in advance. This will be 4 root 3. Okay, so this is 4 root 3, 4 root, not 4, 2 actually. The square root of 4, that is a 2. So we have a 2 root 3. Even here 2 root 3. 2 root 3. Okay, so even this one was supposed to be 2 like that. Yeah, so that is more simplified now. I think now we can now simplify it nicely. So we've already multiplied with the first one. Okay, now we come to 2 root 3 multiplied by 2 root 3. Okay, now it makes sense. So 2 multiplied by 2, that will give us a 4. Okay, plus then a 3 root 3, it just gives us a 3. Okay, so we're going to have a 3 there. Then we come to the other side, negative 2 multiplied by root 3, negative root 2 multiplied by 3, we're just going to have negative 3 root 2. Okay, then we come to negative 2 multiplied by negative root 2 multiplied by 2 root 3. Okay, so here we have to be very careful. So I'm going to have negative 2 root 6. Okay, root 6. Okay, now that I've got that, what do we now do? Okay, so okay, yeah, I think we're okay. Yeah, I think we're good. Then down, I'm just going to get this one and do the difference of two squares, because what we're supposed to do is supposed to multiply with this one, which is just the difference of two squares. So in this case, if I square this one, 3 squared, that is a 9, okay, minus 2 squared, that is a 4, the square root of root 3 squared, that will give us a 3, that 3 multiplied by 2, that will give us a 12, okay. 9 minus 12, what does 9 minus 12 give us? Okay, 9 minus 12, what does it give us? I'm saying this is 12, right? Yeah. So we're going to have 9 minus 12, that is negative what? Negative 3. Okay, that is what we have there. Then what do we now do from here? We're just supposed to simplify what we now have on top. So we have a lot of figures on top. What can we simplify? We've got 6 root 3 plus 4 multiplied by 3, that is a 12, minus 3 root 2 minus 2 root 6, like that. Okay, I think, is there anything that we can simplify from here? No. Okay, so you can even leave it from there, it's still fine. Okay, yes, you can even leave it from there. So basically, this is how you simplify these expressions. You just have to make sure that you do the conjugate there. Okay, so let's solve also the other one. We're taught to solve each of the following quadratic equations. Give your solutions in the form of a plus ib, where a and b are real numbers. Okay, so since we have a lot of questions, we are just going to solve. Also, we are just going to show you how you just solve this one quickly. So ib, we're still talking about something that is very close to complex numbers. Yeah, so we're solving these quadratic expressions. So this we can't solve it using the product and sum method, because throughout it is they are positive numbers. So in this case, I'm just going to use the quadratic formula. A in this case it is 1, b in this case it is 4, c in this case it is 5. Okay, according to your quadratic, x is equals to negative 4 positive or minus the square root of b squared minus 4ac. Okay, let's write our quadratic here, because it's like we'll be using it so much. X is equals to negative, what am I even writing? Okay, why am I even writing the quadratic? Okay, just for negative b positive or minus the square root of b squared minus 4ac over 2a. Okay, so we're just going to be replacing every time we want what we want. Okay, so let me just now wrap this part. b squared, that is a 4. Okay, 4 squared, that will give us 16 minus 4ac. 4, a is 1, c is 5. Okay, 4 multiplied by 5, that is a 20. Okay, so here I'm going to put a 20. Everything divided by 2a. A is 1. Okay, 2 multiplied by 1, that is just a 2. Then I solve. X will be equals to negative 4 positive or minus, I find the square root of 16 minus 20, that is a negative 4. Okay, everything over 2. Then I'm supposed to now simplify this. So this is going to be equate to x now will be equals to negative 4 positive or minus. Now you should understand that if you have a negative 4, it can also be written as negative 1 multiplied by 4. Okay, now the square root of the square root of 4, you know that it is a 2. However, the square root of negative 1, it is I. Okay, that is what this question is just trying to achieve. It's negative I. So in this case here we're going to have 2i, okay, over 2. Then you simplify from there because they want it in that form. So in this case, negative 4, it is going to be divided by 2 plus 2i divided by 2. That is the first one. The second one, it will be x will be negative 4 divided by 2 plus, oh actually this time it's minus, okay, minus 2i divided by 2. So those are the two values of x that you are going to have. And if we are going to write them on the other side, you are just simplifying this expression. Negative 4 divided by 2, so therefore x will be equals to, that is negative 2 plus, the 2 and the 2 are going to divide. We're just going to remain with an I. Okay, that is the first one. Then another value of x is negative 4 divided by 2, that is negative 2. Then negative 2 divided by 2, that will give us a negative 1i or negative I. So these are the two answers for this one. So basically I think this is how we are going to solve all of them. So let's just solve B. So for B we are saying x squared minus 6x plus 10 is equals to 0. In this equation, what is A? Okay, what is A? A in this case, for B we've got 1, then B we've got negative 6, then C we've got a 10. So just replacing in the equation, x is equals to 6, which is our B, positive or minus the square root of B squared. B squared, 6 squared, that is 36, minus 4ac. A is 1, C is 10. So we got 4 multiplied by 1 multiplied by 10, that will just give us a 40 there. Divided by 2a. A is 1, so you are just going to have a 2 there. So we have 6 positive or minus the square root of 36 minus 40. That will give us negative 4 over 2. Okay, so we only have two answers here. 6 6 plus or minus the square root of 4, we said it is 2. The square root of negative 1, we said it is I over 2. Okay, then from there now we just have to solve. So the first answer of x, what is it going to be? Okay, so the first value of x is going to be 6 divided by 2, that is a 3. Then if we're going to start with plus 2 divided by 2i divided by 2, that is I. That is the first answer. Then the other answer is 6 divided by 2, that is a 3. Then negative 2i divided by 2, that will be negative I. Okay, so these are the two answers that you're going to have for the second question. Okay, so if you're going to solve the other ones, it's the same thing. If we're going to talk about C, x squared minus 2x plus 8 is equals to 0. So you just have to say what A is. A in this case is 1, B in this case is negative 2, C in this case it is 8. Then you just solve. Okay, so in this case x is equals to negative B. Okay, negative B, in this case, since we already have a negative there, you are just going to have a positive 2 there. Positive or minus the square root of B squared. B squared, it is negative 2. Negative 2 squared, that is a 4. Minus 4ac. Our A is 1, our C is 8. 8 multiplied by 4, that is a 32. Divided by 2a. 2a is 1. Okay, so basically that. Then you just solve. X will be equals to 2 positive or minus the square root of 4 minus 32. That will give us a negative 28. Okay, divided by 2. Okay, basically that. Then negative 28, since it doesn't have a perfect square, 2 into 28, that is 1. 2 into 2 is 1. 2 into 8, that is a 4. Okay, so even this one, it can't really do much. What number can we go for? Okay, what number can we go for? 4, right? 4 multiplied by 7. Yes, 4 multiplied by 7 is the one that is going to give us negative 8. Okay, basically that's so I've got 2 positive or minus. We are saying 4 multiplied by 7, that's the one that gives us 28. Now the square root of 4 is a 2. Okay, 2. Okay, so this will be 2i. Then the 7 is going to be the one with the root. Okay, over 2. Then you find 2 divided by 2, that is a 1. If you are starting with plus, it will be plus. Then the 2 and 2 are going to cancel. We're going to have I root 7. Then if you're going for the negative 1, it's just going to be y 1 minus I root 7. So basically, you're able to see the pattern. So basically, this is how you solve these type of questions. Not very complicated. Then you can solve the other ones. They are the same. The concept is the same. When we come to question number 12, or we also have question number 13. Okay. So for question number 12, we are told to solve for x and y in each equation below. Okay. So what are we doing? I think it's not very much different from what we just previously solved. Okay, so we've got let's say x plus y I 2. Okay, 2 plus 5i is equals to 17 minus I. So this one is just about us, expanding and solving like that. Okay. So if I'm going to start with x multiplying with everything that is in the bracket here, I'm going to have 2x plus 5xi. Then when I start with the yi multiplied by 2, I'm going to have plus 2yi. Then if I multiply the yi multiplied by 5i, I'm going to have plus 5yi squared. Okay, is equals to 17 minus I. Okay, then what then now I'm supposed to do is what? Okay, I can I think I can solve the do we even have like terms? Okay, let me just simplify the one with I squared. So it will be 2x plus 5xi plus 2yi. Then the 5i squared, I squared, you know that is a negative, so it will be negative 5y actually is equals to 17 minus I. Okay, so this is y. Okay, is there anything that we can also simplify from this equation? Okay, so let's now solve the other part. I'm going to put the ones with I, factorize them alone, and I'm going to put the ones with just numbers alone. So I'm going to put, because you know these are complex numbers, you can't mix them. So I'm going to have 2x, then I've got minus 5y. I'm going to put it as if this one is a real part, of which it is, then plus the other one. I'm going to put it alone. I'm going to have 5xi. Okay, so this is 5x and this is 2y, and all of them have got I. I'm going to factorize the I outside. So I'm going to have 5x plus 2y, then I put the I outside. This will be equals to 17 minus I. So this is how we solve complex numbers when you are given to solve equations. Allow me to wrap that part. Okay, so now that we've wrapped that part, what this means now is that the ones we're going to set the whole thing to be equals to 17 minus I, but of course we're going to first get the real part the real part is 2x plus it's minus actually 2x minus 5y. This will be equals to the other real part, which is 17. Then the imaginary part, we've got 5x plus 2y. This will be equals to, we've got negative I there. We're just going to say negative 1, okay? Because the I and the I are the ones that are telling us that these ones are the same. Then we just have to solve these equations, okay? We can solve them simultaneously if we want, okay? But these ones, are they really complicated? Let's solve which one can we solve? Okay, which equation can we solve nicely here? Okay, I think it wants to work. Let's just solve them simultaneously. So I've got 2x minus 5y is equals to 17. I've got 5x plus 2y is equals to negative 1. Okay, now that I've got this, what am I going to do? If I multiply, okay, what do we do here? Simultaneously, what are we supposed to do here? Okay, so I don't know any method that we can use. I think I'm just going to use substitution method. Let's say we multiply okay, 2 and let's say I put 2 there, here I put 5. Okay, I put 5 on top, I put 2 down. Okay, then I set one of them negatives. I can put the other one, this one, negative, so that we eliminate x. So this will be negative 10x plus 25y is equals to negative, that is 35, that is 5 multiplied by 1, that is 5 multiplied by plus 3, that is 85. Then when we come down, 2 multiplied by 5, that is 10x plus 4y is equals to negative 2. Then we add, okay, plus. So 10x, you know, negative 10x plus 10x, that will give us a 0. But when you add 25y plus 4y, that will give us like 29y. That will be equals to negative 85 and a 2. That will like add up, giving us 87. Okay, then 29 on both sides. Okay, so y in this case is going to be 29. 29, I think it's going to be 3, because if I say 9 multiplied by 3, that is a 20, that is a 27. Okay, then 3 multiplied by 2, that is 6. 6 plus 2, that is 8. Okay, so able to see that this is negative 3. So y is equals to negative 3. Then in any of the equations, you just now subtract what y is. Okay, so we can even get the first one. We've got 2x minus 5, y we're saying it is negative 3, is equals to 17. So in this case, we've got 2x minus, actually plus 15 now, is equals to 17. That is 2x is equals to 17 minus 15. 2x in this case will be equals to 17 minus 15. That will give me, is it a 2? Then I divide by 2 on both sides. X will just be equals to 1. Okay, so those are the values of x and you know y, because we're solving for x and y in each of the equation. So basically, this is how we solve these questions. It's not very complicated. Solve the part that they've given to you, then simplify it. Okay, so basically that. Then we come to question number 13. Okay, so what do we do from here? Okay, let me just mention something here. We've solved this part. Then in case maybe some people have challenges solving B, okay, so it's also one of the simplest. It's not very different. So here you're just supposed to cross multiply. Okay, so you're going to have 11 plus 10i will be equals to what you have as 4 minus I, then x plus y I. Then here now you just simplify these ones. You distribute them like we did for the other one. Okay, then the answers, then now you equate the way we had to equate. Basically that's not very complicated, but anyway, we can try. Then which other one? What about the other one? Okay, first for these other ones, you are supposed to first simplify. Okay, you simplify, you multiply the numerator and the denominator by the conjugate of 1 plus y. Okay, then you solve it the way we solve it, like any other complex numbers. Then you're going to get a certain answer. It's just going to be maybe, let's say, 4 minus 6i. Okay, then also you come to the other one. Okay, you also solve it like that. It's also going to give you maybe a certain number. Let me say 3 maybe plus maybe 6i. The i's and the i's, you can work with them. The 3 and the 3, you add them. Then it's going to become like one single number, like maybe let's say 7 maybe plus 12i. That's an example. Is equals to 3 minus 6i. Then you equate. This is equals to that. That is equals to that. Then you find the values of x and y. Basically, you're going to have some x and y's in the equations. So basically, this is how you solve all these ones. Okay, so I just wanted to make mention in case people who have challenges solving that one. Okay, so now we come to question number 13. Now, question number 13, we're given that z1 is equals to that, z2 is equals to that. Then we're told to find z1 and z2. Okay, z1 multiplied by z2. That is the modulus or the magnitude. Okay, so first you have to find first what z1 and z2 are when you just solve them just like that. So we're going to have 1 minus 3i, then 4 minus 3i. Okay, then you just solve that. So how are we going to do that? You're just going to solve the way we've been solving the other ones. 1 minus 4i, 1 minus 4 minus 3i, so that will be 4 minus 3i. Okay, then negative 3i multiplied by 4, that will be negative 12i. Negative 3i multiplied by 3i, negative 3i, we're going to have positive 9i squared. Okay, then we're going to have 4 minus 3i minus 12i plus, actually not really plus now, it's going to be minus 9. Okay, because we said I squared is just the same as a negative. Okay, now that we've got this, we're now going to have 4 minus 9, that will give us a negative 5. Okay, then negative 3i minus 12i, that will give us negative 15i. Okay, then we found that as the answer for these in the bracket. So now we're supposed to find out the magnitude. The magnitude of this would mean that you're going to get each of them, then you square them. So I'm going to have negative 5, I square this, then plus, then I'm going to have negative 15, I square that, then I solve. So that will be the square root of negative 5 squared, that is a 25. Okay, then what am I have? Plus plus negative 15 squared, negative 15 squared, that is 225. Okay, then I add what I have in the brackets, that will be the square root of 25 plus 225, that is like 250, right? Yeah, 250. Then 250, since you cannot leave it there, you can even simplify it, because we've learned how you simplify SURDS. So you can divide numbers there. But you know that when I multiply 10 multiplied by 25, it will give me 250. 25 is a perfect square. So in this case, I'm going to have 25 multiplied by 10. Now the square root of 25, that is a 10, that is a 5. Okay, so I'm going to have 5 root 10. Okay, that will be the final answer for this one. Okay, so basically that, not very complicated. Then for the last one, let's solve the last one. The last one we're adding. Okay, so for the last one we are adding. Okay, so for the last one we've got z1 plus z2. Okay, so you're just replacing. So we've got z1 is 1 minus 3i, then we are adding it plus 4 minus 3i. Okay, so in this case, what are we going to do? Just normal algebra. So that would be 1 minus 3i plus 4 minus 3i. Okay, so 1 plus 4, that is a 5. Okay, then negative 3i minus 3i, that would be negative 6i. Then we find the magnitude for that. Okay, so the magnitude for this now would be this, the magnitude for zi plus z2, that would be equals to the square root of 5 squared plus the square root of negative 6 squared. Then we solve. Okay, 5 squared, that is a 25, plus negative 6 squared, that is a 36. 25 plus 36, 25 plus 36, that is 5 plus 6, that is 1. Okay, then that is 11, carry 1, then 2 plus 3, that is a 5, plus that 1, that is 61. That would be the square root of 61. So this would be the final answer. Okay, so actually we've reviewed all the concepts in this tutorial sheet. So thank you for watching to the end. Please don't forget to subscribe to our channel.